Hello and welcome to the SAP HANA Academy. My name is Dennis van Kempen, and in this video tutorial series we will discuss SAP HANA administration. This video provides a brief overview of multi-tenant database containers. Multi-tenant database containers is a new feature of SAP HANA Support Package Stack 09. Here we see how this works. We have a single SAP HANA host. This is the Linux server with operating system, hardware and storage. And on the host we have installed an SAP HANA system. And on the system we have created two tenant databases. Then we have two different applications, App X and App Y, that connect to their own tenant database. An SAP HANA system running in multiple container mode is identified by a single system ID, the SID. And this would be the purple box. Databases are identified by the SID and a database name, so the green and blue boxes. All the databases in a multiple container system share the same installation of database system software, the same computing resources, and the same system administration. When you are connected to the SAP HANA system, that is, to the system database, you can start and stop the entire HANA system, perform monitoring for the entire system, configure system level parameters, the INI files, create and drop tenant databases, disable features on the tenants, and scale out tenants to multiple hosts, and we'll talk about that in a minute. Back up the whole system, including all tenants, and restore the whole system. And typical administration tasks when connected to the tenant are tenant monitoring, create users, create or drop tables or any other database object, indexes, views, procedures, and so on, back up the tenant, and configure tenant-related parameters. So each tenant database is self-contained and fully isolated with its own set of database users, database catalog containing the list of database objects, repository for development, persistence, backup, traces, and log files. On the left, you can see how we might have solved this isolation requirement in earlier versions of SAP HANA. Here we see a single database with two different schemas. A schema is a container for the database objects owned by a particular user. The difference here is the degree of isolation. You cannot back up or restore the schemas independently. You cannot scale the schemas independently when using multiple hosts or a distributed system. You cannot set any configuration parameter to enable or disable features. You cannot set password policies independently, and so on. In cloud scenarios, you cannot host App X for company A and App Y for company B as schemas in a single database. No way. You can, however, do this with tenant databases. No problem. Here's another approach used with previous editions of SAP HANA. Here we see two installations of HANA on a single host. This gives you the required level of isolation, no problem. However, this does not provide a good use of shared resources. You have two systems, so you need 2 times the amount of memory, CPUs, and also more storage. You have 2 installations of HANA, so that's 2 times the maintenance, software updates, and so on. Using multi-tenant databases is much more cost effective. Same isolation level, but for less dollars. So multi-tenant databases provide a high degree of isolation at a much lower cost. Very much in demand for cloud computing. In another video in this series, we talked about SAP HANA architecture. We explained how client applications connect using either SQL or MDX. We talked about web connections and the built-in web application server called HANA Access for extended services. We talked about HANA Studio and the new web-based development and administration tools. And we also talked about the role of the different HANA servers, the index server or database engine, the name server, and so on. If you're not familiar with these concepts, you may want to watch that SAP HANA Architecture Overview tutorial video first. Here we see the main components of an SAP HANA system with multi-tenant database containers. We have here 3 database containers, 1 system, and 2 tenant databases. on a single host. We can see that with HANA Studio, for example, you connect to either the system or the tenant database. Same for any other client application that connects using ODBC or JDBC. As you can see, in a multiple container system, only the system database runs the name server. The name server contains landscape information about the system as a whole, including which tenant databases there are. The name server also acts as an index server, that is, as the database engine for the system database. So there is no index server process for the system database. Unlike the name server in a single container system, the name server of the system database in a multiple container system does not own topology information, that is, information about the location of tables and table partitions in databases. We talked about this in architecture overview video as well. Database-related topology information is stored in the relevant tenant database catalog. Servers that do not persist data, such as the compile server and the preprocessor server, run on the system database and serve all databases. With persisting data, we mean that these servers do not require data to be saved to disk. Storage today can be of the traditional hard disk type or flash memory, so often the more generic term persistence is used. What matters is that the data persists or survives a loss of power. RAM memory, of course, doesn't. So some processes need persistence. We back them up, for example. The compile server only compiles stored procedures, so we will not lose any transactional data if this process suddenly stops. Same for the preprocessor. We call it the search engine. Tenant databases have a dedicated index server process or database engine, and the application server or access engine runs embedded in the master index server of the tenant database by default. Now, if needed, this can be configured as a separate service. The web dispatcher runs as a separate service on the system. It routes incoming HTTP requests from clients to the correct access server based on virtual host names, and this is part of the network configuration. Here we have a multiple host system, a distributed system with multi-tenant database containers. So we have one multiple container system, one SID, with 3 tenant databases distributed across 3 hosts, and that's in 2 workers and 1 standby. To ensure availability, an instance of the system database runs on all hosts, the worker and the standby, in a single master and multiple workers configuration. Tenant databases can be created on a single host or can be scaled out to run on multiple hosts. We see this with tenant DB1 and tenant DB2, but not with DB3, for example, that's running only on a single host. As already mentioned, by default, the access server, the application server, runs embedded on the master index server of the tenant database, but can be configured to run as a separate process. Now, if a host fails, the standby instance will fail over all active databases and their services. Okay, so much for this overview on multi-tenant database containers. In another video, we will show you how to install HANA in multi-tenant mode, how to migrate HANA to multi-tenant mode, and how to administer HANA in this new setup. Multi-tenant databases are documented in the SAP HANA Administration Guide. You can access and download SAP HANA documentation free of charge on help.sap.com/HANA. Thank you for watching this SAP HANA Academy video.